Hello everybody. Welcome to Creating the Basic Adaptable Game Engine Library, Part 24, Starfish Collector 1.0 Code. Well, we've talked about what the Starfish Collector game involves, and it's a very simple game, kind of like a Hello World program, but for game development. And in this video, we're going to start writing the code. However, there are a few things we still need to add to the library. The first, I've gotten some good feedback from people who've been watching these videos, so thank you for that. We're going to make a slight modification to the texture class in the way the constructor works and the way the file name is parsed. In the rectangle class, we have a set position method. We'll also add a set size method for convenience. And the major change we need to add that bit of game functionality is we need to be able to know when two sprites overlap. So we need to write an overlaps method for the sprite class. We also have to initialize our collision shape. So we need to set up a get boundary and we need to initialize our boundary rectangle. All right, so let's go ahead and open up our development environment. So as always, I'm using IntelliJ. And now let's go ahead and, before we start our game, a couple of small changes to the library. The first, in the texture class, I've heard that some people have had some issues loading a file with this format. The reason I really want to use this format is later on in the video series, I'd like to show you how to create executable jar files so you can run your games independently of a development environment. So that's why I've been using this syntax, but I've heard that with other development environments, you might have some problems. So the way we'll fix this, I'm going to comment out this line of code for now and replace where the image is created with image file name rather than this file name that we parsed before. One possible problem with this bit of code is JavaFX tries to not bother you sometimes. And if it couldn't find the file name, it fails silently. So no exception or error message was generated. All right, so we'll set that up. And in addition, I would also like to set up another constructor as well. So just for consistency, I'm going to create a new constructor here, public texture, which will take in the parameter string image file name. And we'll do very much the same things that the texture load function does. Right, so in this case, I'd like to say, this image is equal to a new image with the image file name. I'd like to initialize the region. So region is a new rectangle. And then we'll need to extract the width and height of the image. Right, so I can copy a lot of this code right here. Right, so extract the width and the height from the image, and then use that to set the size of the region. All right, so this will be a parameterized constructor in case you're not as comfortable using the load functionality. Right, there are some cases in which we will want to start with an empty texture, specifically if we want to reuse an image file, but we want to use a different region. But I think that this texture constructor will also be very handy in what follows. So let's see, I've got that code set up. Let's also head over to the rectangle class. We'll make a slight modification to that. Don't want to move it. I want to open the rectangle class. Now before we had a set position method, and that's very convenient if the size of your rectangle is not changing, but the position is. Right, let's also add an analogous method in case the size of your rectangle changes, or in case you're just initializing the size. Let's make this public void set size. We'll take in a double width and a double height. And I would like to, again, use the set values method because that also calculates the right edge and the bottom edge. But in this case, I'm going to use the pre-existing left and top data and just use the new width and height parameters. Right, so this set size method will come in very handy, as we'll see in just a moment. Right, so we've changed the texture class a little bit, our new constructor. We've changed the rectangle class a little bit. Now let's go over to sprite. This is one of the major changes that we need to make. We need to start setting up the boundary rectangle. Right, so right now when we initialize the sprite, we set up the position, texture, and boundary, but these are all empty objects. So what I'd like to do now is, let's see, whenever we set the position, we can also change the position of the boundary object. So in this set position method, I'm also going to set the position of our boundary rectangle. Similarly, when we set a texture, we'll be able to know what the width and the height of this sprite will be. And we would also like to set the size of the boundary to those same dimensions initially. And if you change the size, the width and the height, right, that changes the size of the image which is getting drawn on the screen. If we change that, we naturally want to change the boundary rectangle as well. All right, so that's set texture. For set size, we'll do the same thing. Boundary.setSize, do this new width and height. So the boundary gets initialized and it changes in sync with the size of the sprite. Next, let's actually create a method. For instance, if we're moving our turtle across the screen, we might add values to the position rather than using the set position function. So we have to be very careful that we make sure the boundary is updated consistently. The easiest way to do that is to control access to the boundary object by creating a getter method. So this will be a public rectangle get boundary. And what we'll do here is first we'll update the boundary just in case. And so let's say boundary.setValues be position.x, position.y, and then what else? We'll need this width and this height. In case these values might have changed. Actually, probably width and height won't change. So we could just say boundary update the position. And then we'll return that new boundary. Or not a new object per se, but an updated boundary object. And finally, let's say a public Boolean function called overlaps. Two sprites overlap if their boundary rectangles overlap. So what we can do here is return, I'm using this for clarity, this.getBoundary, check to see if that overlaps the other object's boundary. Oh, and of course we have to say, what are we checking for overlap with? I need an argument sprite, let's call that other. And so when we're overlapping, we're getting the boundary, and we're automatically updating the position, again, if the position values have changed. Again, if we change the position with set position, this might be something we don't have to worry about, but we want to be careful in general. Okay, so we've got our overlaps method. I think that's everything we're going to need. And now we're ready to write our very first game. So let's create a new class. I'm going to call this class Starfish Collector, version 1.0. And to begin with, it extends the game class. Now already, these little wiggly red lines means we have an error. Game is an abstract class and we must implement two methods. So public void initialize and public void update. In theory, we could run this right now. Let's actually do some things. Set title, Starfish Collector. And let's set the size of the window. This is set window size to 800, 600. So that's how large the background I'm going to use is. And just for fun, let's try running this. And so I'm going to run. Let's see. Let's run Starfish Collector. Should see a window pop up. Excellent. It's got our 4:3 aspect ratio. It's got the correct title up here. Very good. Now I have a bunch of images I'm going to use for this game. I've added them to my images folder. They'll all be available on GitHub later on. I have my background image. I've got the water here. I've got my turtle who's going to run around and collect the starfish objects. And I have a "you win" message which will appear on the screen at the end of the game if you win. All right, so let's go to Starfish Collector. Let's create some objects up here. I need a sprite. Let's make a sprite called, let's just call it water because it's our water background. Let's create a sprite, no, let's create a group first. Let's create a group called Starfish Group because we're going to have more than one starfish. We want to keep them organized in a group. Let's create a sprite called Turtle. And let's create a sprite called Win Message. All right, in our initialize method, we're going to start setting up all of these sprites, starting with water. That's a new sprite. And I already know that that's an 800 by 600 size sprite, so we won't need to set the size. It'll fit in the window very well, pretty well. So let's set the texture, water dot set texture, and I'm using that alternative constructor we set up. So this is in the images directory. It's called water.png. And even after we create this object and we set the texture, we do need to add it to the main group in order for it to get rendered. So we can say group.addWater. Can save that, and let's go ahead and run. I'm a big fan of running code as frequently as possible. Just make sure everything's working according to plan. Cool. And already, there's actually a little bit of a problem right here, which I'm expecting, and I know how to fix this. The image of the water has this kind of ripply, sandy boundary, which is supposed to go all the way around. You might notice it's cut off. The reason it's cut off down here is because when we set the size of the stage, that size includes the size of this title bar, right? I wasn't taking that into account. Now there's a nice easy fix for this. If we go over to the game class, right down here where we set window size, again, the stage includes the title bar, so that's not actually what we want. So what we'd like to do is use a method on the stage called size2scene. Right, so this will resize the window so it exactly fits everything in the scene, including this newly enlarged canvas. And so that's the new line of code that we'll use right here. We have to make sure this happens after we resize the canvas, so it takes that into account. And now, if we go ahead and run Starfish Collector again, we should see that the water image fits nicely in the window. Right? And we see we've got that entire background. All right, much better. Next, let's go ahead and add some more things. Let's add the starfish next. All right, so let's set up Starfish Group. That's a new group. And then I'm going to load the texture, but I'm only going to load it once, and I'm going to reuse it for each starfish. So texture, let's call this starfish texture. It's equal to a new texture. The images folder, it's starfish.png. All right, so I've got my texture. Let's also, just for readability, int starfish count. How many starfish do you want? Change this number to whatever you like. I'll put in 20 because why not? And then let's set up a for loop. Let's make int I start at 0, I less than starfish count, I plus plus. And we're going to create some new starfish. So let's make a sprite called starfish. It's a new sprite. And we need to set its position, but just for fun, we're going to give it a random position. Let's say double x equals math.random. Now, math.random by itself gives you a random decimal number between 0 and 1, but I want to go somewhere across the entire screen, so let's multiply this by 800. And then double y is equal to math.random times 600, because my window's 800 by 600 pixels. And then starfish, let's set the position to be this x and y value. Next, let's set the texture. Starfish.setTexture to the starfish texture. And then let's add the starfish to the starfish group. So starfish group dot add that new starfish. Excellent. Let's see. Yeah, we're not really using the variable I here. It's just kind of a counter. Once we're done adding everything to the starfish group, part of the reason we're using the entity group sprite framework is so we can add groups to groups. So we need to make sure we add the starfish group to the main group in our game. So group.add starfish group. All right, with that little bit of code, let's go ahead and run this again. What we should see is 20 starfish scattered across the screen at random. Let's go ahead and run that. All right, there are starfish everywhere. And if we close and rerun, we should see the starfish in a new configuration. There we go. One thing which may be a little bit worrisome is some of these starfish could be partially off the edge of the screen. Right now, the XY coordinates give you the top left, and what if the Y coordinate is something like, something close to 600? You might get something which is mostly off the screen. In fact, I look really closely. You might need to zoom in on your video. I see a little bump right here. I think there is a starfish which is off screen. So in that case, I'm going to actually change this code a little bit. Instead of a random number from 0 to 800, let's say I want to restrict that to be within a smaller range. Instead of like 0 to 800, let's say I want to shrink that to the range 100 to 700. I can change this code up a little bit. Math.random times 600, that gives us a random number from 0 to 600. And then add 100 to that, it'll give us a random number between 100 and 700. Right? So instead of taking the full 0 to 800, we're kind of shrinking that range and then shifting it over a little bit. We'll do the same thing here. Let's shrink this to 400 and then plus 100. And this will just cause the starfish to cluster a little bit more in the center. If we go ahead and run, we should see no more starfish in the sand. The border areas, they should all be in the water. All right, good starfish. All right, some of them are just lined up very nicely. Very good. Yeah, that's cool. Okay, next, let's go ahead and add that turtle. All right, so turtle is going to be a new sprite. Let's set this up in the corner. So set position, maybe 50-50. And turtle, let's say set texture to be a new texture. I'm only using this texture once, so I don't need to save it to a separate texture object. Turtle.png. Cool. And then group.add turtle. Now if we go ahead and run that, we should see our ocean plus starfish plus a turtle. There you go. It's not interactive yet. We need to add some code to the update method. This is going to be very similar to our test game example. Right, we're going to ask the input if a key is being pressed. Right, remember we have multiple methods. Is key just pressed is for discrete actions, but for continuous actions we use is key pressed. So for instance, if key pressed is right, then I'll say, oh, I don't want a semicolon there. If the right key is pressed, oh, and I need an if because this is a conditional. If the right key is pressed, then I'll say turtle.position.add values, and we're going to the right, so maybe I'll add 2, 0. And because of the way this is working, since we're kind of addressing position directly by adding values to it, the boundary doesn't get updated. Right? The boundary would only get updated if we called turtle set position. That's why we're using the get boundary method, which also updates the position of the boundary. Okay, so I'm going to go ahead and copy. I'm going to copy this 3 times. 2, 3. And so if the turtle, or if we press the left arrow key, we'll add -2 to the x. If we press the up, we're going to add -2 to y. And if we press down, we're going to add +2 to the y. Remember, the reason we're adding +2 to go down is the positive y-axis points downwards in most computer graphics. All right, there's update. Let's go ahead and run this. Hopefully I'll be able to press the arrow keys and move that turtle around the screen. Hey, there we go. Now the turtle's not collecting anything yet because we haven't added the overlaps function to our update function yet. So let's check that. We're going to set a for loop. In fact, I'm going to use something called for each syntax. For each entity, I'll call the entity entity in starfish group.getList. Now the reason I'm saying for every entity is, remember, groups, they keep a list of entity objects. Now you and I know that Starfish group, it really only has sprites, but still this is not valid syntax, right? Because again, in general, groups can contain other things. So I need to write this as an entity, and the very first thing I need to do in my for loop is cast this to a sprite so I can use the overlaps method. So maybe now I'll say sprite starfish is equal to, I'm casting the entity to a sprite, right? Putting the class name in parentheses casts that. So now I have access to the sprite methods. Now I can say if turtle.overlaps starfish, then we will remove the starfish from the starfish group. So starfish group dot remove starfish. All right, let's see if that turtle can collect the starfish. Wouldn't be much of a starfish collector game if you could not collect the starfish. All right, so go ahead, turtle. Hey, there they go. The turtle is a very talented starfish collector. All right, so at this point, we can get all the starfish, and then your player might wonder, am I done? I'm not sure. Right? There's no sense of closure, and for that we need to display some kind of a win message when the game is over. So what I'd like to do now is add one more sprite. Right? This is the win message sprite, and I'm going to initially set that to be invisible. So win message is equal to a new sprite. Let's see, win message. Let's set the position. It's not going to be perfectly centered, but I'm going to take a guess. Maybe let's set this to 300, comma 300. Win message dot set texture. We're going to create a new texture. Images slash, this was called uwin.png. Of course, you can substitute your own image files if you wish. Let's also say win message dot visible equals false. Already I feel like we should create a set visibility method for this. It feels weird to access this field and not the other fields. So we'll do that soon. And then group.add win message. And now, when do you see the win message? Well, when the size of the group is 0. So let's go under update. Let's see. Where do we want to put this? We can put it wherever we want. We can say maybe in the for loop. If starfish group dot size equals 0, then let's say win message dot visible equals true. Okay, so if there are no starfish left in the group, we should be able to see that win message. Okay. So let's go ahead and run this. All right, let's go ahead and collect some starfish. Hey, we win. Cool. Yeah, this isn't centered very well, but we could just shift that over a little bit on X and up a little bit on Y. But that's it. Very fun. One thing you might wonder about is, why is the turtle still moving at this point? Well, it's up to you. You can have the turtle continue to move, or you can say, if the game is over, if the win message is visible, you could exit out of the update method really soon. You could do something like if win message dot visible, then return. Right, that means if the win message is now on the screen, then we're not really returning a value since this is a void return type, but it skips out on the rest of the function and the turtle becomes frozen in place. So if you wanted to stop the turtle from moving at this point, you could add in this bit of code right here. Also, I do want to center that a little bit more, so maybe I'll move that to 250, 200, something like that. But yeah, there we go. It's Starfish Collector 1.0. It's got really the basic functionality of a game. It's not the most fun game in the world, but it really brings together all these different concepts. And our next task is to figure out how to make this game better. So in the next set of videos, kind of the second third of this series, we're going to add different features to this game to make it more polished. Things like, maybe we'll implement some better collision detection. We'll make it so the turtle can't go off screen. We'll add a title screen. We'll add some physics-based motion so the turtle speeds up and slows down. We'll add some animations to the game. Oh, there's lots of good things we can add. But this video is already pretty long, so we'll save that for the next video. And thanks for watching.